We're going to look at graphing absolute value functions using the vertex and the slope. The general form of an absolute value function is f of x equals a times the absolute value of x minus h plus k. The vertex is at h comma k. Now notice it says minus h, so that means it's really the opposite of what you're going to see in the equation. If it says x minus 3, then h is actually a positive 3. And if it says x plus 3, then h is actually a negative 3. And that's your vertex. We saw in our exploration about transformations that when the a is positive, it opens up, and when the a is negative, it opens down. A is also the slope of this right branch. So in our parent function, y equals the absolute value of x, the a is 1. And so my slope is up 1 over 1, up 1 over 1. That's my right branch. My left branch is the negative version of that, up 1, left 1, up 1, left 1. And so we can use that information to draw our absolute value graphs without having to make a table. So our first example is f of x equals 2 times the absolute value of x minus 4 plus 1. We're going to identify the vertex h comma k. So 4 comma 1. Remember, it says minus h, so what I'm subtracting is the positive 4, and that's why my vertex is at positive 4, 1. And we're going to put it on my graph, positive 4, 1. And then my a is positive 2. So it opens up and has a slope of 2 over 1. So from there, we're going to go up 2 and over 1. Up 2 over 1. Up 2 and over 1. Oops. And then we can draw our branch on the right. And then we're going to do the opposite for the left branch, up 2 and to the left 1, up 2 and to the left 1, up 2 and the left 1. Now you don't have to draw the steps like I did, but in order for you to see what I'm doing, I have to draw it out because you can't see my hand move. And so then when we have our final graph, those steps can be erased. And that's the graph of 2 times the absolute value of x minus 4 plus 1. The domain and range, we talked about that last week, so it's important that we understand domain and range. The domain is x such that x is contained in the set of all real numbers. The range for this graph starts at positive 1 and is greater than, so its y is greater than or equal to k, which is 1. So your domain is always going to be all real numbers because you can plug it in to, you can plug any number into this function and you're going to get an answer. So let's look at another one. Y equals negative 1/2 x times the absolute value of x plus 1. Now, my vertex is h comma k, and this is plus 1, so really it's minus negative 1, so my h is at negative 1 comma 5. Negative 1, positive 5. My slope, my a, is negative 1/2, so it opens down, and it has a slope of 1 over 2, down 1, right. So from my vertex, we're going to go down 1 and right 2, down 1 and right 2. So we go down 1, right 2, down 1, right 2, and we can keep going. There's my right branch. And my left branch, I'm going to go down 1 and left 2. Here's my left branch. And this one's wider. So we would call this transformation a reflection in the x-axis, and the wider is your your vertical shrink factor of 1/2, and then your translations. So our domain is all real numbers. That's an ugly one. And my range, y such that y, everything here is less than my vertex, so less than or equal to my k, which is 5. So if it opens up, it's less than, if it opens up, it's greater than, and if it opens down, it's less than. Let's do another one. So we get y equals negative absolute value of x plus 6 minus 2. So my vertex is -6, -2. It's opposite here because it's minus and -6. That's how they get the plus. And then -6, -2. And then my a is -1, which means it opens down. And the slope is 1/1. So we're going to go down 1 and right 1, and then we'll go left 1 for the other side. So from here we're going to go down 1, right 1, down 1, right 1, and then down 1, left 1. So my domain is x such that x is contained in the set of all real numbers. My range, x, y's are less than this vertex at -2. So y such that y is less than or equal to -2. Put that on there. Oops. All right. This one. Y equals 3 times the absolute value of x minus 4. Your vertex is 4, comma, there's nothing out there. So that just means it's 4, comma 0. And my a is +3, so it opens up. And my slope is 3/1, so I'm going to go up 3 and right 1 and then left 1. So 4, 0 is on the x-axis, and my slope is going to go up 3/1, up 3/1, up 3, left 1, up 3, left 1. So we're going to go up 3/1, and then up 3, left 1. And my domain, x such that x is contained in the set of all real numbers. And my range, y such as y is, it's greater than 0. Greater than or equal to 0. Okay, so y equals -5, absolute value of x minus 3 minus 4. Now whether it says f of x or y, we graph it the same way. Our vertex is at 3, -4. Our a is -5, so it opens down. And my slope is 5/1, so we're going to go down 5. We always go up or down for the new number on top, and then right 1. So I'm going to start at +3, -4. And we're going to go down 5/1, and then down 5 and left 1. So down 5/1, down 5/1, left and right. Again, my domain, domain is x, such that x is contained in the set of all real numbers. And my range is y. All these values are less than -5, so less than or equal to -5. The vertex is part of the graph, so therefore it is equal to. We're going to look at what happens and how is it different if their coefficient is inside the absolute value. And we talked about how that's a horizontal shrink factor of 1/2. And so that really affects the vertex because this is inside. So when the coefficient is inside, we have to take this 2x minus 1, set it equal to 0. Because the vertex happens where inside the absolute value equals 0. So we're going to add 1. And we would want it to be at 1 if the 2 was on the outside. And what it's done is it's moved it to 1/2. So my vertex is at 1/2 comma -4 instead of 1 -4 that it would have been if the 2 was on the outside, which is why it's a horizontal. It moved from 1 in, it shrunk it in. So we're at 1/2 -4. And it opens down because it's negative. And lucky for us, the slope is still the coefficient on the x, 2/1. So we're going to go down 2 and over 1, but from that 1/2. So when we go over 1, we need to stay in the halfway point. And there's your graph. So it's not much different, but when the coefficient is inside the absolute value, you just have to set this equation equal to 0 to get that vertex.